Hi girls, now we are going to revise all kinds of problems of thermochemistry that you might be asked about in the coming quiz. Chemistry revision. Question 1. A block of copper of unknown mass has an initial temperature of 55.2. Initial temperature means T1 equal 55.2 degrees Celsius. The copper is immersed in the beaker containing 98.7 grams of water at 23.6 degrees Celsius. So we are having a block of copper. So this T1 is for copper. And we have T1 for water equals 23.6 degrees Celsius. Then we put the copper in water and they reach thermal equilibrium, means the final temperature for both was 24.4. So T2 for copper 24.4 and for water also 24.4 degrees Celsius. What is the mass of copper block? And he gave the specific heat capacity of copper, specific heat capacity of water, you all know, 4.18, and the mass of water also you are given. Remember that when we are working here, if you are given mass of water or volume of water, they will be treated in the same way. Now we are going to apply. We have a beaker containing water. The mass of water was 98.7 grams and the temperature of water was 23.6 degrees. And then we immersed a copper block in water. The copper block, before we put it in water, its temperature was 55.2 degrees. Both of them reached to a thermal equilibrium where the final temperature became 24.4. Remember the law which say that heat gained equal heat lost. So heat lost from the metal, heat lost by the metal equal minus heat gained by water. Sum of heat energy will be transferred from the copper to water, reaching equilibrium thermal temperature. You know the formula Q equal mc delta T. So we have mc delta T for the metal equal minus mc delta T for water. And then we'll apply the formula and substitute. He's asking about the mass of the metal. He's asking what is the mass of copper block. So this one is unknown. C specific heat capacity of copper, which is given to you 0.903 joule per gram Celsius, times delta T change in temperature. The initial temperature of copper was 55.2 and the final temperature was 24.4 equal the mc delta T for water, the mass of water 98.7, specific heat capacity of water, it will not be given to you, you should know it, 4.18 times change in temperature. The initial temperature of water was 23.6 and the final was 24.4. And then we'll apply until you get the mass of the metal. Remember that the mass of the metal should be given, you should calculate it in a positive value. If you get it a negative value, means that you did a mistake. You should repeat the working out of your equations. Product of this was minus 330.0528. The product of this was minus 27.8124. You have 3 marks for showing out your work. And then you are going to divide in order to calculate the mass of the metal. You need to divide 330.0528 over here minus also 27.8124. Okay, the minus will get cancelled, so you will get your result in a positive value. Remember that you round out your answer to 3 significant figure. Okay, make your rounding the final step. Here we wrote it 1, 2, 3, 4, 5, 6, 7 significant figure. And this answer was 1, 2, 3, 4, 5, 6, 7 significant figure. Get the final answer and then round it to 3 significant figure. This question is a multiple choice question, but based on Hess's law. You are given here the enthalpy of formation of carbon dioxide, enthalpy of formation of water, and the enthalpy of formation of C2H4. How did we know it's the enthalpy of formation? Because we got a compound from elements in their standard form. And then you are asked to calculate the enthalpy change for the following reaction. C2H4 plus 3O2 gives 2CO2 plus 2H2O. How to do this calculation? First, let's look at the equations given to us, and you are asked to find its delta H. Here is unknown, and the values you are given. I got the enthalpy of formation of carbon dioxide. Here, carbon dioxide in the product side. Here is also in the product side, so you are not going to make any change here. You are just copying it. So I will copy now X kilojoules. And then water, you got the enthalpy of formation of water in the product side. Here and there. This means that you are going to also copy the value without any change. Then C2H4 in the product side, but here is in a reactant side. Remember that the heat of formation of any element is 0. So the delta H, as you know, equals sum of enthalpy, standard enthalpy of formation of products, minus sum of enthalpy of formation of reactants, equals X plus Y minus Z plus 0. So equal X plus Y minus Z. So which letter you are going to choose? We are going to choose B. In this problem, you are asked to calculate the enthalpy of combustion of butane C4H10 to produce carbon dioxide and water. And you are given enthalpy of formation of some compounds. You are given the enthalpy of formation of carbon dioxide minus 393.5 and the enthalpy of formation of water minus 285.8. And you are asked to calculate delta H for this reaction. First of all, we need to look at the equation given to you to compare the position of the compounds carbon dioxide and water. If you are given here enthalpy of formation, means that both of water and carbon dioxide will be in the product side because it's enthalpy of their formation. So both of them are products. Comparing this with our equation, we have also carbon dioxide and water in the product side. This means that you are not going to flip or reverse the equation. But what we should do, here the enthalpy of formation of 1 mole of carbon dioxide and the enthalpy of formation of 1 mole of water. But the equation you are given here the enthalpy of formation. I have here 4 moles of carbon dioxide and 5 moles of water. This means that the value for carbon dioxide will be multiplied by 4 and that of water will be multiplied by 5. Then the enthalpy of formation of element is 0, as you know. Here you are asked to calculate the enthalpy of formation of C4H10. So this one is unknown. And he gave the enthalpy of combustion of standard enthalpy of combustion of 1 mole of butane, which is this value. So you are already given this value, delta H. Write the equation first. Standard enthalpy of combustion equal, because this is combustion, so delta H here is the standard enthalpy of combustion of butane, equal sum of enthalpies of formation of products minus sum of standard enthalpies of formation of reactants. What are the products and reactant here? So it equals, these are the products, both of them. So the sum of enthalpy of formation of product will be minus 393.5 times 4 plus minus 285.8 times 5 minus enthalpy of formation of reactants. C4H10, which is unknown. And here you have the enthalpy fraction. Remember, the enthalpy fraction is enthalpy of combustion of butane, because butane has been burned in oxygen to produce carbon dioxide and water. And this is the definition of enthalpy of combustion. The energy produced, or the enthalpy produced, when 1 mole of a compound is burned completely in excess oxygen. So this equals 2.7 times 10 power 3. You will do your calculation. You are going to multiply 393.5 into 4, and also will multiply 285.8 into 5, get the final value, and then minus standard enthalpy formation of C4H10. Okay, and then you will flip, put this on the other side with positive sign, and put this value on the other side with a positive sign also. Then you are going to find the value of standard enthalpy formation of C4H10, which equal minus 133 kilojoule per mole. This multiple choice question is about the activation energy and the enthalpy of reaction. If you look carefully at the graph, here is the reaction progress, and on the y-axis we have the energy. Here is the reactant side, and there is the product side. You can see that the enthalpy of the product or heat of the product is less than heat of reactant. This will make the overall reaction exothermic. And the value of delta H will be negative sign. So the forward reaction is endothermic? No. At equilibrium, activation energy of the forward and reverse reaction are equal. We said this never happened. The activation energy of the reverse reaction is much higher than in case of the forward reaction. Activation energy of the forward reaction is greater than the activation energy of the reverse reaction. Let's see how can we get this. Here is the reactant side and the product side, and here is the direction of the forward reaction. Where is the activation energy here? It's between the reactant and the peak of the graph. This is the value of activation energy in the forward reaction. If the reaction is going to go in the back direction, opposite direction, so this will be reactant, and here we'll have the product. And now the activation energy is between the reactant and the peak. This is the activation energy of the reverse reaction or the backward reaction. It's very clear to you that the activation energy of the reverse reaction is much higher than the activation energy of the forward reaction. So which one we can choose here? Yeah, activation energy of reverse reaction is greater than the one of the forward reaction. This graph or energy profile diagram, it shows you the reaction, here reaction coordinate, and the potential energy. It's very clear that A1 is reactant, so now A and C are correct in this area. Activated complex. Activated complex, they are at the peak. We have 2 and 4 at the peak. So 2 and 4 are activated complex. 5 is a product. So we are going to choose A. Find the value of the activation energy of the reverse reaction from the potential energy diagram. The following potential energy diagram, and answer the question below. So what is the value of activation energy here? Activation energy is between the reactants and the product. So it's between activation energy is between the reactant and the peak. The peak here is at 100, and the reactant is here is the activated complex. So what will be the value of activation energy? It will be 100 minus 40 equal 60 kilojoules. The coming 3 questions are theory questions. They don't involve calculations. Question 1. Explain why collision between 2 reacting particles don't always yield a product. Yield means produce. Why sometimes the collision doesn't result in formation of a product. This happens if the collision was ineffective collision. Ineffective collision. And when the collision is ineffective, if the reacting molecules don't have enough energy or they are not in the correct orientation. Question 2. What is the activation energy of a reaction? Activation energy is the minimum amount of energy needed to make a reaction take place. This is the definition of activation energy. Explain when this energy is related to the formation of the activated complex. When the reactants are provided with the activation energy, the old bonds between the atoms are broken, leading to formation of the activated complex. We explained before, if we have two reacting molecules, like one molecule is AB and the other molecule is CD, in order to react, first they should gain enough energy to collide successfully and be able to react. Once this happens, the bonds in the reacting molecules will be broken. So once the molecules have the activation energy, the old bonds will be broken and new bonds will be formed. First, activated complex will be produced. Activated, like here, the bond here becomes weak between A and B. B start to come close to C. The bond between C and D becomes weak. So here, the old bonds are broken or start to break, and the reactants start to orient themselves in the correct way in order to produce a successful product. Question 3. If A to B is exothermic, how does the activation energy of the forward reaction compare with the activation energy of the reverse reaction? Remember, this is a very important question. Activation energy of the forward reaction is smaller than the activation energy of the reverse reaction, and we'll just explain this in the previous slide. Let's answer this long question. The question is very important. It has 10 marks, but it's very easy to earn them. Let's look at the energy diagram, which show the rearrangement reaction of methyl isonitrile to acetonitrile. So this one is the methyl isonitrile reactant, and this is the acetonitrile product. Here is the reaction progress. This means that this side is the side of the forward reaction, and here is the energy or potential energy. Is the reaction represented by this diagram endothermic or exothermic? Once you see the energy or the heat of products is below, means less than heat of reactant, this means that the reaction, the forward reaction will be, yes, correct, exothermic. And then explain or justify heat content of reactant is greater than heat content of product, or you can say it in the opposite way, heat content of product is less than heat content of reactant. B. What does the chemical structure at the top of the curve represent? This one, what does it represent? Activated complex. C. What does the symbol EA refer to? EA is the activation energy. Consider the following reactions. N2 plus 2O2 gives 2NO2. Okay, and the enthalpy of this reaction was 60 kilojoule per mole. And the other reaction, 2NO plus O2 gives 2NO2, and the enthalpy of this reaction is minus 100 kilojoule per mole. Find the enthalpy of this reaction. How to calculate it? Here we are applying Hess's law. We need to look at reactants and product to see if they are in the correct side of the arrow or not. Here we have N2 and O2 are on the reactant side, and here N2 and O2 are also in the reactant side. And they have one mole. Okay, oxygen will see what will happen to it, but we have 1 mole of nitrogen. In the second equation, NO is on the reactant side, but in our equation, it's on the product side. This means that you are going to flip this equation. So in order to calculate, I will write the two equations. N2 plus 2O2 gives 2NO2. And the delta H equals 60 kilojoule per mole. Second equation, when you flip it, it will be 2NO2 gives O2 plus 2NO, and the delta H equal, yes, you reverse the sign, it will be positive 100 kilojoules. Overall equation, okay, you know the right and left side are cancelled. So N2 plus, here 2O2 and 1, 2 minus 1 equal 1. Oxygen 1O2 gives 2NO, and you will add the value 60 plus 100 equal 160 kilojoule per mole. So the energy is 160 kilojoule per mole. Consider the reaction. CH4 plus 2O2 gives carbon dioxide plus water, and the delta H for the reaction equal minus 900 kilojoule per mole. When 4 moles of methane react with 4 moles of O2, how much energy will be produced? Here I have 1 mole of methane has been burned in 2 moles of oxygen to produce, so 1 mole methane react with 2 mole of oxygen to give 900 kilojoule per mole. So the mole is the mole of the reactant. If we use 4 moles methane and 4 moles oxygen, 4 moles methane needs 8 moles oxygen to react completely, because the ratio here is 1 mole methane to 2 moles oxygen. If I have 4 mole methane, not all of them are going to burn. Only 2 moles of methane will burn in 4 moles oxygen, to keep the ratio 1 to 2, like in the previous equation. So if we are using 1 mole, 900 kilojoule are produced. So if 2 moles are burned, double the amount. So 1800 kilojoules will be produced, will be released. The answer is C. This question is asking what's true about an endothermic reaction. Energy is released over the course of reaction. In endothermic reaction, energy is not released, it's absorbed. The bonds in products are weaker than the bonds in reactant. Yes, in endothermic reaction, the bonds in the products are weaker than the bonds in the reactant. That's why the curve for endothermic reaction is like this. Products are much energetic because the bonds are weak. When the molecule is more energetic, the bonds get weaker. This question is about the enthalpy, standard enthalpy formation of methanoic acid. So which equation is good representative for standard enthalpy of formation? Methanoic acid is HCOOH. So what are the elements that may produce this compound? You should have hydrogen, you should have carbon, and you should have oxygen in their standard form and in their standard state. Standard state of hydrogen is gas, standard state of carbon is solid, standard state of oxygen is gas. HCOOH. And it's an acid liquid, so this one should be L. So now let's balance our equation. I have 2 hydrogen here, and this is 2 hydrogen, that's correct. C and 1C, 2O and 2O. The equation is full balanced. So which one is matching the one I wrote? It's equation 2. So equation 2 is the correct choice here. This question is about specific heat capacity. Two metals of the same mass but different specific heat capacities were subjected to the same amount of heat. So we have two metals have the same mass. We heat them equally, so they are exposed to the same amount of heat. Which metal undergoes greater change in the temperature? Specific heat capacity, let's go to the definition again. Specific heat capacity is amount of energy required to raise the temperature of 1 gram of matter 1 degree Celsius. So if the substance need more energy, means it has higher specific heat capacity, in order just to change the temperature or to raise the temperature 1 degree, so this means that it will not going to be very hot. While the one which has very low specific heat capacity means it needs just a very small amount of energy for its temperature to rise. So the metal with lower specific heat capacity is the one which show greater change in temperature. So great change in temperature happen if the element has low specific heat capacity. And the opposite is also true. This problem is about the quantity of heat and heat capacity. Calcium oxide was introduced as a substance that can be used to heat water quickly for heating packs used in picnics. Calcium oxide reacts with water and the following reaction occurs. When calcium oxide is added to water, reacts producing calcium hydroxide, and this reaction is exothermic reaction. A student wanted to design a heating pack using 160 grams of water from 30 to 55 degrees. So we need to heat the water from 30 to 55 degrees Celsius. Answer questions A and B. Question A. Calculate amount of heat in joules that the water needs to absorb for its temperature to change by this amount. So we need the quantity of heat. Q equal mc delta T. In any calorimetry experiment, you should use this formula, mc delta T. Q, we are looking for it. M is the mass of water, and you are get it 160. C, specific heat capacity 4.18. Change in temperature, which is 55 minus 30, equal 160 into 4.18 into 25. And you are going to calculate the value of quantity of heat in joules. And it should be given here to 4 significant figure. So you should choose the correct scientific notation to get your answer to 4 significant figure. In B, he's asking to calculate the mass of calcium oxide the student need to use to code this temperature change. Here, so as per our equation here, 1 mole of CaO produces minus 64, or you can just use the value 64 kilojoules. But the amount of energy we need is 1.672 times 10 power 4 joules. We need here it's kilojoule, so no need to convert the unit. We need to know the mass of calcium oxide. So he is asking about mass, not moles. And you are given a value of mole. So the first step you should do is to change mole into mass. And this happens when you divide if you need to calculate the mass, you need to multiply the number of moles into molar mass. So the number of moles is 1, molar mass is 56.08. So 56.08 into 1 gram of calcium oxide produce 64 kilojoules. So how many grams are required to produce this amount? You will do normal cross multiplication. So it equals 1.672 times 10 power 4 into 1 divide by 64. And you will get the answer in grams. Here we have the energy profile diagram, and you are asked to answer some questions. First, you are asked to label, identify E, Q, X, Y, and Z. Letter T represent, look carefully, letter T, this one. It's the difference between reactant and product. So the energy change from reactant to product is the enthalpy of reaction. So T is the enthalpy of reaction, delta H. Q is the difference between reactant and the peak, the activated complex peak. So this is the value of EA for the forward reaction. So it is the activation energy. X is the enthalpy of reactants. And Z is enthalpy of product. What's left is only Y. Y is the activation complex. Next question. In the reaction above, is the reaction above endothermic or exothermic? And justify your answer. Look again at the graph. You can see that the enthalpy of product is less than enthalpy of reactant. And this means that the forward reaction is exothermic. This will be your answer. Then, which reaction is forward or reverse? Justify which reaction is favored, forward or reverse. We prefer the reaction which require less activation energy. So this means that the forward reaction is favored because it needs lower activation energy than the reverse reaction. Remember, in exothermic reaction like this, activation energy of the forward reaction is just Q, this value only, is the activation energy of the forward reaction. But if the reaction is going to be reversed, and here we'll have the reactant and there we'll have the product, the activation energy now will be all of this. This is the EA for reverse reaction. This means that the reverse reaction is not preferred because more energy is required for the reaction to start. Here we have a multiple choice but similar question. Look at the graph carefully before you start to answer. Remember the position of reactant, product. Heat of product is more than heat of reactant, and this means that the forward reaction should be endothermic. And the endothermic means the value of delta H will be positive value. So this reaction is endothermic with an enthalpy change of 40 kilojoules. We have another endothermic with a value 100. exothermic reactions are all wrong. And the endothermic with negative value is completely unacceptable. So now we need to make sure which one is correct, A or C. Look at the graph. Where is the enthalpy change? How can I calculate it? It's between reactant and the product. So it is this area, 80 minus 40 equals 40. So we have chosen A. Second, forward reaction is, so you will mention faster or slower or as fast as the reverse reaction, and you will give the reason. We said this reaction, in this reaction, the activation energy is very high. Where is the activation energy? Between reactant and the peak, the activated complex. This is the activation energy. If with the equation, if the reaction is reversed, making this reactant and that product, so the activation energy will be only this value for the reverse. If less energy is required, the reaction is favored. So the forward reaction here, the forward reaction is favored or not? It's not favored, so it will be slow because it has higher activation energy. Activation energy for the forward reaction here is C plus X, or which is equal B here. But if the reaction is going to be reversed, activation energy will equal the value of X only. So the reverse reaction is more preferred, the forward reaction is not preferred. Which of the following is true regarding the energy of the activated complex as compared to the energy of reactant and product? Energy of activated complex is lower than energy of both reactant and product, or energy of activated complex is greater than energy of both reactant and product. Remember that the activated complex is usually at the peak, at the top, so it has the highest energy. Which of the following is true for the reaction with low activation energy? Low activation energy means the reaction will be fast because a small amount of energy is just enough for the reaction to start. So reaction is said to be fast. The idea of this question seems to be repeated, so we can do it very fast this time. Activated complex, the peak. Which is N here. Activation energy of the backward reaction. This is the forward reaction. The backward reaction will go in the opposite side. So where is the value of activation energy for the backward reaction? Backward reaction, this will be reactant and this one will be product. So the value between reactant and the activation complex. So it will be G. Enthalpy of reaction, the difference between reactants and the products. Reactant and product. So it's K. Reactants are here. Enthalpy of products is here according to the forward reaction. Okay, the product themselves are L. Take care, N here is the enthalpy of the product. In order to form this product, the enthalpy of product is this value from 0 to 220. Question B. Is the reaction represented above exothermic or endothermic? Once you see it going down, it's a exothermic reaction. exothermic reaction. Justify your answer. Heat of product is less than heat of reactant, or the opposite. Heat of product is less than heat of reactant. This question is exactly repeated, the same idea. Letter correspond to activation energy of the forward reaction between the reactant and the peak. This is the activation energy, so it's C. The letter which correspond to change in enthalpy, reactant and product, it's B. Letter correspond to the products, product is Z. Very simple. Thank you, my dear student. I hope you enjoy learning today, and I hope to have some of those questions in the coming quiz, inshallah. Thank you.